Hey everyone, welcome. In this video, we're going to look at the law of cosines. It's a follow-up to law of sines, where we're going to look at side, side, side. And that's a case of where you don't know any angles of a triangle, but you know all three side lengths. So let's start there. Refer to your law of cosines on the identity sheet found in your Google Drive folder for your class. I won't be able to write a lot of formulas because they're just so long. I will, and what I mean by that is all of them. Like, I do plan to still write out the one that I'm going to use, but make sure you've got your identity sheet handy so you can refer to it, and you'll see why I pick certain formulas out of that big group of law of cosines. All right, so let me jump right in. If you know all three sides, you're going to want to use the alternate form of your law of cosines. There's one little group where you see all lowercase letters and then a cosine of an angle at the very end. And then there's another group that starts with the cosine of an angle and it has all your side lengths on the other side. And that's why we're going to pick this one, is because we know A, which is 8, C, which is 14, and B, which is 19. So be very careful to plug all your numbers in. Be also very careful to calculate these. You might want to use parentheses around the numerator, hit divide, and then parentheses around the the denominator. Separate them with parentheses. This big fraction comes out to negative 0.4509. Now think back to when we covered inverses. Cosine was the cosine inverse. We looked in the top two quadrants to find the angle that had this particular x value. Now that's kind of a gnarly x value. I do want to point out it's negative. So from quad 1 or quad 2, we need to decide where the x values are negative, and that's quad 2. Now, quad 2, you have angles that are more than 90 but less than 180. That means it's obtuse. And I put a note here, since cosine of angle B is negative, angle B has to be obtuse. Put it in your calculator, cosine inverse of that negative decimal number, and it does come out to 116.80 degrees. Once you know an angle, then you can go back to using law of sines because we have a complete proportion here. We know side B and angle B. It's your preference on whether you want to find A or C. Just pick one and let's set it up. I randomly chose A. Sine of A. Oh yeah, and also on the law of sines from the last video, all three of those fractions can be inverted and it's still a true identity. So I'm going to put, since I'm looking for an angle, I'm going to put the sine of an angle on top. Its opposing length is 8. And then I'm going to use sine of 116.80 over 19. One fraction, you got to know both parts. The other, at least one. Multiply both sides by 8. Be very careful calculating this out. Sine of A is 0.3758. There's actually two angles that would have a positive sine value of this. You'd have one in quad 1 and you'd have another in quad 2. One good thing about angle B being obtuse is it's the only angle that can be obtuse, because you can't have two obtuse angles in the same triangle. You surpass the 180 degree limit. So invert your sine in this decimal. So angle A is sine inverse of 0.3758, and that's just a little bit over 22 degrees. Now we know two angles, so you can go back to get the third, subtract the ones you know from 180, and there's our third angle. This triangle, we're given side B, angle A, side C. The angle in between is 25 degrees, capital A. Its opposing length is the only side we don't know. Now, back in the law of cosines on your identity sheet, you're going to look at that other group of formulas. We're looking for a side instead of an angle. These are the ones that are written out with all your lowercase letters followed by cosine of the included angle. That's the angle included between the two sides given. A squared is equal to B squared plus C squared, 9 squared plus 12 squared, minus 2 times B times C times cosine of the angle in between. A lot to calculate. Be very careful to square the first two. Do not square the back two. It's all straight through multiplication. You hit a plus sign between those two, a minus sign, and then you just let it rip, multiply all the way through. A squared is around a little more than 29 if you do the calculation right. I recommend to hold on to several decimal places because to get A, you got a square root. If you round a decimal early, you lose accuracy at the end. So it is kind of important to hold on to several values. 4 past the decimal is usually enough. Sometimes throw in a fifth. And this is the length of side A. Now we have all three sides. We just found A, we know B, we know C. It's these two angles of B and C that we're after now. I randomly picked B. I could have gone for C, but sine of B over length B is equal to sine 25 over 5.4072. I purposefully held on to several decimals so it improves the accuracy throughout the problem. Multiply both sides by 9. This fraction calculates out to 0.7034. And now what I mentioned in the previous example is in the first example, we had a 102 degree angle given. And that is obtuse, and you can only have one obtuse angle in a triangle. That one is acute, so there's still room for an obtuse angle. I went over here to the left and I marked off the upper two quadrants. Sine, which is the y value, remember that, sine is the y value, a positive 0.7034. Using your calculator, sine inverse, let me put that in here. If I can get my thing to work. Here we go. There we go. Sorry, y'all. I didn't mean for the take forever to select that. Sine B is equal to 0.7034. So one of your angles, when you take sine inverse of that decimal, you get 44.70 degrees. That is a quad 1 angle with a y coordinate of 0.7034. There's actually another one, and 44.70 serves as the reference angle. So if you take 180 and subtract that reference angle, you get this other angle. It's 135.30. This one can qualify as well. So you've got two different possible, like a set of different answers. So let's finish it with this first angle, and that's why I called it B1. If B is 44.70, and from this diagram, that's the one that looks right. 180 minus 25 minus 44.70 gives you one possibility for C. If B is acute, C will be obtuse. This other angle, if B is obtuse and measures 135.3, then that forces C in this scenario to be acute. Believe it or not, if you draw two separate triangles and use the lengths here, 5.4 for A, 9 for B, 12 for C, and you leave angle A at 25, you can actually construct two separate triangles where 44.7 and 110.3 serve as the other two angles, or B is obtuse and C is acute. It's pretty interesting. Let's do an application. The pitcher's mound on a woman's softball field is 43 feet from home plate, and the distance between the bases is 60 feet. So we have a square outlining the situation. All four sides are 60 feet. How far is the pitcher's mound from first base? Now, for those of you that play softball, you know that the pitcher's mound's not exactly halfway between home and second base. Same thing's true with baseball. Like professional baseball, the mound is, the rubber's, I think, 60 feet. And excuse me if I'm wrong on that. I think it's around 60 feet, but I think it's ballpark 127 feet from home to second base. Anyway, we know the pitcher is going to be a direct path to home plate. These baselines are 60 feet each. The distance from the pitcher's mound to first base, I'm going to call that X because that's what we're asked to find. Notice we do have a triangle, not necessarily a right triangle, but we have a side, and an angle between, which is a perfect candidate for law of cosines. X squared is equal to 43 squared plus 60 squared minus 2 times 43 times 60 times cosine of 45. All the steps are written out. 45 is the angle opposite of the length we want. And with law of cosines, those are going to be on the opposite ends of the equation. Calculate everything on the right side of the equation. You get just a smidge over 1800. Take the square root, 42.43. So it's pretty dang close to 43 feet from the pitcher's mound to first base, but a little short. A follow-up question is, how far is the mound from second base? Maybe we're looking for that. Because of the 45-45-90 triangle that's formed, if you go from home to second and only concentrate on the right half of the playing field, or at least the diamond part, then we can calculate home to second using properties of a 45-45-90. 45-45-90. It's going to be 60 times the square root of 2, which is 84.85 feet. Now that's home plate to second base. In part A, we determined that the pitcher's mound is 42.43 feet from home plate. Subtract those, and they're basically identical. So even though the problem tells us it's not halfway on a softball field, it's pretty darn close to halfway. Now, finding the area of a triangle if you know all three sides. It's a different formula from the law of sines video that we did just before this one. Area, and this is called Heron's Formula. Heron's Formula. This is actually, in my opinion, more applicable than the side angle side area formula from the previous video, because a lot of times in a triangle you'll know the length of all your sides. They don't have to be any right angles, just know all three side lengths. If you do, A, B, and C are going to be your side lengths. S is called a semi-perimeter. So in this formula, A, B, and C will be given, you have to calculate S, which is the semi-perimeter. Here's the formula for that. Basically, add up all three sides and cut it in half. Semi-perimeter is half the distance around your triangle. Well, half of 168 is 84 feet. And I put a note here, that's called the semi-perimeter. Double check that calculation, even triple check it, because when you switch over to the area formula, your semi-perimeter gets used 4 times. Once as a standalone number, and then it's semi-perimeter minus each side of your triangle one at a time. Clean it up a little bit. In other words, do all your subtractions. If you're careful, put it all in the calculator at one time. Just use your parentheses heavily. If you clean it up, these are the 4 numbers you multiply together. Gives you 1,281,168. And then when you square root that, you will get 1,131.89 square feet. If you want to round that up to 1132, that's totally appropriate. Kind of watch your rounding on your online homework. Sometimes it's specific, sometimes it just throws caution to the wind. If you have any questions about this video or the problems pertaining to the law of cosines, reach out by email, phone call, or stop by the office during office hours, or if you want to, ask about them in class, and if we have time, I'll certainly try to help you out. Have a good one. Thank you.